fantastic, considering construction, Oktoberfest, so I really appreciate you chose us tonight. And I know a lot of you did that because of our special guest speaker, Dylan, who comes to us all the way from Winnipeg. So first I want to start off by thanking our full season sponsors. Why did this go away? Sales Software has sponsored both of our streams every month, so that's both the .NET stream and this stream, which was the same stream, but we're using it this year for a mishmash of different topics as well. So, and also thanks to Microsoft for also being a full season sponsor. And congrats to our supporter draw winners. We had the draw last meetup session, and the 3 winners of the lovely backpack with some nice little items inside was Samantha Campbell, Peter Gerkens, and Alexei. So they've been contacted, and they'll be making arrangements with Ken to pick up their prizes because they were not at the meetup to actually collect it there. And if you have any questions or suggestions or recommendations on things you'd like to see in future meetups, reach out to any one of your CTT organizers through the meetup site. Let us know topics you want to see that maybe we haven't covered that might be of interest to you, or if you prefer different formats of sessions and things like that. We always use your feedback and implement it in future sessions. And if you're on Twitter and you love to tweet, please use the hashtags tonight, our user group hashtag, as well as DevOps and Microsoft, since that's tonight's topic. And at the end of this meetup, please remember to go onto the meetup page and rate it. Dylan bases his self-confidence on the rating score, so it's very important that you go on there and rate him and tell him how amazing he is. And upcoming events. So we also have another meetup coming up in 2 weeks. This one will be at the Country Hills Community Library, so that's out on Homer Watson, Block Line Road area. We have Damian Brady, who is from Australia but living in Canada temporarily, and he goes back to Australia January 1st or something like that. So this is our last shot to actually have him come to a session where he's accessible to us. He recently joined Microsoft as a cloud developer advocate, and yeah, come on in. And his sessions are always entertaining, and he is talking about DevOps for any language, any platform. So he says he has demos in 3 different programming languages. It's going to blow your mind, so you definitely want to come to that. And there's always the Hacker Nest meetups. The next one is going to be held at MyoVision on November 13th, and those ones always get a good 100 to 200 people out of those ones, those socials, so they're a lot of fun. And without further ado, I will pass the dongle to Dylan. And let him slide over here.
Hi everybody, I'm Dylan Smith. Live in Winnipeg, work for Microsoft as of somewhat recently, I guess 4-ish months now. I work on a new team called the DevOps Customer Advisory Council. We work with Microsoft's biggest customers and help them be more successful at DevOps, specifically with Azure and VSTS. Before that, I was a DevOps consultant working for Imaginet, traveling the world, doing basically the same thing. That's me on Twitter. I'm part of a group called Western Devs, as is Lori. That's how we know each other, and that's, I guess, why I'm here. And I guess the story, or what I'm going to talk about today, like I said in the description, this is not me pitching you VSTS. I got some demo-ish stuff, but I'm not really doing demos. Sure, we're going to see some VSTS stuff, but the focus and my intent is definitely nothing to do with VSTS is great, here's what it can do, rah, rah, rah. What I'm going to do today is tell you the story, the journey that the team that writes VSTS, the journey that they've gone on over the last 7 years really, but especially in the last 4 or 5 years. And the way that they do DevOps internally, 4 years ago versus today is just totally different. They had a lot of problems 4 years ago, and it all kind of started when they took their on-premise product to TFS and decided, hey, we're going to release this in the cloud, and we can't release it every 2 years now. We're in the cloud. We've got to release it every 3 weeks. And basically everything about how they work, shipping an on-premise product every 2 years to shipping a cloud product every 3 weeks, like everything about how they work, how they plan, their work, how they do builds and deploys, how they do tests, creating like operations group to run the live site, something that they've never had to do before and had to figure out from scratch. Like everything about how they work had to change. So I'm going to talk to you a bunch about their current practices, but more interestingly about kind of how they got from where they were to where they are. At some point in this talk, I'll probably even bring up their live VSTS account and show you some live pull requests and planning dashboards and stuff like that. We'll see. I've probably got 4+ hours of content here that I'm going to try to cherry pick the most interesting hour and a half, 2 hours or so. So we'll see what we get to. feel free to interrupt me. I can answer any questions. We actually I organized an event in Redmond 3 weeks ago where we brought in 100 people, partners, MVPs, and a bunch of Microsoft internal people, and we gave them basically 3 days, 20-ish hours of content to teach them how to tell the story. So after that event, I know a lot more now, so I can answer those questions. Okay, so the developer division of Microsoft, what they call DevDiv, that's about 3,500 people, and this is the division that makes basically all the developer tools: Visual Studio, VSTS, TFS, .NET Framework, ASP.NET, all that stuff. The team we're talking about, the VSTS team in particular, is about 800 people out of that group. Of those 800 people, I don't know the exact number, but I think 500 to 600-ish are engineers, and the rest are other. We'll talk about what that is in a bit. They're split up into about 40-something feature teams. Each team is 10 to 12-ish people. So that's the size of the team we're talking about. So this is obviously some of the challenges you face doing DevOps with an 800-person, 40-team product. It's going to be very different than what you guys may face in a one-team product. But hopefully you hear some interesting nuggets of wisdom here. And the way they work today, right, to spoil it, if you've read Brian Harry's blog or anything, I'm sure you know this, is they work in 3-week sprints. At the end of every 3 weeks, they ship an update to VSTS. And actually, as you'll see, that's not entirely accurate. They ship a somewhat major update every 3 weeks. They ship daily, sometimes multiple times a day. But every 3 weeks, they ship a somewhat major update that's all the 3 weeks worth of work in that sprint. All right, and they keep doing that every 3 weeks. Now, at every quarter or so, they roll all that up, and they still ship it TFS on-premise with these quarterly updates. And they go, and they go, and they go. And they've been doing like Scrum and 3-week sprints for quite a long time now. I believe, let me just jump out of here to show some hard proof. I believe we are currently in, why can't I click this? Sprint 125 for 3-week sprints. So they've been, whoa, that didn't work. What the? Let's try a different browser. Awesome. Their website is busted. Really?
That's okay, this is as good as any visual. Most of the time we browse in the code editor anyway, so in the DevTools.
All right, well, it's just the release notes website. It's not like it's an application.
I can vouch for you. 4 years ago, I got a presentation from the program manager of TFS explaining their Scrum process to us.
No, here we go. I'm in it. All right. Well, anyways, I'm not sure why the homepage didn't work, but there's a VSTS release notes page, and this is just to kind of prove that they really, truly have been doing Scrum for 125 sprints, which represents, 6 years or so of Scrum at 3-week sprints. And one thing that kind of proves the value of their transformation, and you see 2017 sprints, it goes back to 2012. If I were to pick a recent one, say this one, I remember this one, this is September 15th, and you just scroll through these release notes. I'm not going to talk through them, but they got some new queries experience, keyboard shortcuts, context menus, some grid stuff, adding folders to the code repo, some pull request features, some new wiki features. This goes on and on. This is just a 3-week sprint. Multi-phase builds, some new notification stuff in releases, on and on and on and on. Get to the bottom here. Jesus, it's long. So that's the release notes for sprint 122. And if I were to go back and pick, truly I'm picking a random one, so hopefully this proves my point. Let's say something from 2014, and I scroll through these release notes, you'll notice something right away. It's much, much shorter. So at the end of all this transformation work, really what they want to do is they want to deliver more value to customers faster. And if you just pick a random sprint that's recent and a random one that's a few years old, you'll immediately notice the amount of value delivered in every sprint is just dramatically more now. And sure, you might argue that maybe their team is bigger now than it was then, and it is a bit. Maybe the features are smaller now than they were then, and they are a bit. But even when you try to kind of normalize for those factors and they run the stats on it, they are very clearly delivering much more functionality now than they were then. And I think on my next slide here, right, this is just the roll-up of one of the things they track, the features delivered per year. And you can see this very clearly it's ramping up. So something they are doing here is working. And the team size may be a bit bigger than it was 5 years ago, but it's not a lot bigger. It's not double or anything like that. So something they're doing is working. So I'm going to talk about the whole journey they went on. There's many kind of sub-journeys. How they transformed, how they do planning, how they transform, how they do testing, or build and deploy, or lifecycle management, or security is surprisingly interesting. So I'm going to tell, and they're kind of overlapping in how they went, but I'm going to try and split up. So I'm going to start by talking about planning. So what did planning look like before, kind of before they went to the cloud? Right, they would typically have about 2-year delivery cycles for TFS. That's kind of split up into an initial planning phase, which is months long. And then they have M1 and M2, milestone 1 and milestone 2. That basically means they ship a beta at the end of M1. Right, so they do the planning phase, 5-6 months, spit out a bunch of specs. Here's what we're going to include in the next release of TFS. And each of those milestone phases are split up into sub-phases. They go and do a whole bunch of coding, and now they're code complete. And now they have a test and stabilize phase, which is actually longer than the coding phase, where they go and find and fix all the bugs and work out all the kinks. And then they do it again. And one of the big problems with this model for them is, all right, they get to the end of M1, they ship the beta, MVPs and enthusiasts install the beta and start giving them feedback. And maybe a lot of times the feedback that they gave us was great feedback, right? You looked at that feature, it doesn't quite work for you, we need to change it, we need to add this. Awesome, we love that. But we're pretty much already booked up till the end of this release. We got a whole bunch of stuff to do and barely enough time to do it. So what are we going to do with that feedback? And the answer usually was, that's great. We'll address it in the next planning cycle. And 2 or 3 years from now, maybe you'll see the results of that feedback. And when they were shipping, TFS, before the days that everybody had a cloud SaaS product, this sucked, but nobody else was really doing better. So they kind of survived. Now in the days of cloud and Amazon and Salesforce and all these competitors and GitLab and GitHub, that's just not going to fly. But they'd never be able to compete with all the cloud vendors that they're competing with, if that was the pace at which they could address customer feedback. So something had to change. And let's skip over that. And they made a lot of changes, but the one thing that underlies the changes, not just in planning, but in everything they do, is they believe that changing the culture is more important than changing the practices. And it's probably the hardest thing to change. They also believe that if you can get the culture right, the practices will just naturally follow. And I'm going to give you guys a bunch of examples of what they did to attack it at the cultural level rather than the practice level. Make people want to do the right things and get rewarded for doing the right things, and just, instead of just telling them, these are the right things, do this. Right? That's kind of the philosophy that they approach all their changes with. And one way that they do this is how they manage teams. So I don't know if you remember, but many years ago, Microsoft used to be famous that every employee gets their own private office. If you guys ever remember these Microsoft days, when they used to be famous for it. That's one thing that changed. Every team, at least in VSTS, they all work in team rooms. And this is a picture of one of the team rooms in Redmond, I believe. And some of the things they do that are kind of important is every team has like a charter and a goal, and they update this about every year. We'll talk about that in a second. But they make a very strong effort to keep teams intact. People don't float between teams. There's a certain point in the calendar where they kind of allow and encourage movement. But they try to keep the people on the team intact, focus on the same goal for at least a year. Right? And the people that do this, they talk about it like, they make the analogy to sports. If you're always changing and swapping team members, it's like you're always in the preseason. Your team's always trying to figure out how to work and how to gel together, but they never quite get there. So they make a very strong effort to put a team together, have a goal, and keep those people together for at least a year, and then maybe swap. And that tends to work pretty good. The other thing they do, which is really interesting, they call it the yellow sticky note exercise. They do this about once a year, and they actually just did it when I was at Redmond last, so about 3 weeks ago. So about once a year, every 12 to 18 months, everybody gets together, and the team leads from the 40-ish teams, they each give a little blurb, a couple-minute presentation on what their team is going to be focusing on the next year, and why their team is so great and every developer should want to be on their team. And then every single person, all 800 people, they get to vote. First, second, and third pick, what team would I like to be on for the next year? So every year, every person gets the opportunity to change teams. And some interesting things happen when we started doing this. We've done this about 3 years now, I think. One thing is about 80% of people pick the same team they were on last year. But it's pretty powerful giving people the option, the choice. I can always leave this team if I want to. Every year I have the chance to leave if I don't like the work, I don't like my boss. 80% of the people choose to stay on the same team, which is good. The vast majority of people get their number one pick for teams. You know, after everybody votes their first, second, and third pick, and the PMs get together and see, can we give everybody our first pick? We got to balance the teams a little bit, and there's some consideration for people with skill sets that certain teams need, and blah blah blah. But in general, the vast majority of people get their number one pick. And there's some exceptions to this, and I'll tell you a story about one. The first time that we did this, about 3 years ago, there was a guy, Vladimir, and he'd been on the same team for years and years and years, and he didn't want to be on that team anymore. So his first choice, his second choice, and his third choice were all different teams. Problem is, Vladimir was a very important developer, and nobody else could do what Vladimir did. Right? So if they let him leave that team would collapse. So Brian Harry, the guy who runs the whole division, sat down with him and said, Vladimir, I'm going to make you a deal. We really need you to stay on this team. We want you to stay on this team for another year. During that year, pick a replacement, train that replacement, and the deal I'll make with you is the next year's sticky note exercise, you're going to get your first choice. No matter what team it is, you got it, first choice. And he was happy, and he did it. Probably got some, good creds. I bet at the next raise and promotion time, he looked pretty good. So I mean, this works pretty good. And I've never seen any other company do this. I think Facebook does something kind of similar, but I think this is pretty impressive that they do this every year. Another thing that we think about a lot when driving kind of culture and around how we plan and manage our work comes from the book Drive. Has anybody read this book by Daniel Pink? No? It's a great book. It has nothing to do with software development. It's a book about how to motivate employees to excel. And he argues that the typical carrot and stick approach that we've used for hundreds of years doesn't really work, especially in knowledge worker and creative worker fields. That it doesn't work, and that people ultimately want three things: autonomy, mastery, and purpose. They don't want to be micromanaged. They want to have some ability to make decisions on how they work and what they do. They want to get really good at something, and they want to see the value of what they're delivering. That these are the things, not so much money. Everybody wants money. Not going to come to work if you don't pay them. But ultimately, these are the things that make knowledge workers and software developers really care and really want to excel. So I say that because, especially autonomy, we focus on this a lot. Actually, before I get to that, let me tell this story. This is a story from the book Drive. And there's two groups, two separate companies that are both competing in the same market. They're making a software product. Right? One group is a well-established company. They got a business plan. They got a bunch of MBAs. They got a whole bunch of money, and they have huge salaries and hire a lot of people. Team B, they're working for free in their spare time because they want to. Right? And if you ask people, which team is gonna win, obviously most MBA type people would say, well, clearly Team A, right? Well, this is a real story, and Team A is Encarta, and Team B is Wikipedia. And clearly, we all know who won that one. If you Google Encarta, the Wikipedia page is the first result on every search engine. All right, so back to planning. So, when we think about how we're going to plan our product and how we're going to manage our work, we think a lot about alignment and autonomy. We call it aligned autonomy. So we can't just have ultimate autonomy and let every person, every team do whatever they feel like doing, because it would be chaos. Right? We want some ability, from the executive leadership level, to have a vision and a strategy and a plan for where we want to go, but at the same time not micromanage people and let teams make their own decisions at a lower level about what they're going to do. So we call that, we want to have alignment at the top, but still have enough autonomy for teams to decide on how they're going to work and what they're going to do. And I'll tell you how that materializes in a second. Right? And obviously you see problems, you have too much alignment, that's micromanaging teams, and then teams, the whole back to the book Drive, they don't feel like they have autonomy, they're not happy in the job, nobody likes to be micromanaged. You have too much autonomy, it's just chaos, and it's hard to steer the ship and have any kind of realistic business strategy. So, how that materializes in the VSTS team is we do these 3-week sprints, and we've been doing them, for 3-4 years, 5 years, whatever that number is. And it started out, everybody did Scrum, right? We sent everybody on Scrum training, everybody's doing 3-week sprints, they're all doing Scrum. Well, that was 120 sprints ago. Since that time, we've given teams a lot more autonomy. So some teams don't do Scrum anymore. Some teams do Kanban, or heck, some teams probably just do like cowboy coding. We don't care. The teams can use whatever process they want to manage the work within that team. But what we do care about is every 3 weeks, that's the cadence that our whole 800-person organization runs on. Every 3 weeks, we're going to have a release, and we expect every team to have something in that release. Every 3 weeks, every team has to send out a sprint mail saying what they delivered in that last sprint and what they plan to deliver in the next sprint. Here's a screenshot of a sprint mail. Typically includes a screenshot, often a 2 to 5 minute video. That's API changes, probably no video. But every team has to do that. We don't care if you do Kanban, Scrum, whatever. But every 3 weeks we're going to ship. You got to have something in there, and you got to send an email out. This email goes out to 1,000 people. There's 40 of them every 3 weeks. Brian Harry, who runs this whole team, he reads almost every one of them, and often he'll reply directly to the engineers who are sending these. So it kind of builds that culture, the flat structure that every engineer is kind of interacting with their boss's boss. So that's one way. We allow teams the autonomy to decide how they're going to manage their work, as long as they're delivering value on the same cadence as everybody else. But we do more planning than just at the start of every sprint. We're going to plan 3 weeks, right? And this is very important. We don't do Gantt charts. We don't spend a lot of time making elaborate plans, but we do spend a lot of time talking about planning and where we want to go. And we think about it at 4 different horizons. So we do sprint plans. Well, for teams that do scrums at least, they do the sprint planning session at the start with the detailed task breakdown or whatever they choose to do to plan out their work for the next 3 weeks. And starting from the far end, we also do a 12-month strategy. Every 12 months, leadership gets together and talks about and figures out where do we want to go over the next year, where do we want to get to. And that's kind of distributed and communicated as a Word doc. It's a 4-page Word document. I was just reading it last night. They just did a new one a month or 2 ago. And it usually has 3 or 4 high-level focus areas, usually based on like market research, competitive analysis, what our customers are telling us. And these are the big 4 things we want to focus on in the next year and why. Every 6 months, we call it a season. We do a big all-hands meeting, and we kind of do a similar thing. We figure out kind of what we expect to do over the next 6 months. The way that discussion goes is it's driven by mock-ups and storyboards, often in PowerPoint, where every team comes to the table. They have about 10-15 minutes to present, and they present their storyboards for what they expect to have done 6 months from now. And leadership and everybody gives them a bunch of feedback, and often we'll tell them to scrap that plan and do something different. We also do a...
Question.
Yeah?
Is the season based on the strategy?
Yes.
Solely?
Well, not necessarily. I mean, the strategy is more big investment areas. And when they do, a lot of people ask me how they do budgeting. So Brian Harry has a certain amount of budget. He thinks about his budget as he has 800 people. And where am I going to direct these 800 people? And sometimes he'll ask for more. He's doing a bunch of internal engineering stuff, and he just asks for another 100 people. But he's got 800 people, and the vision is where he's going to decide. I want to, some of the priorities this year is CI/CD to Azure. They want VSCS to be the absolute best deployment tool if you're deploying to Azure. That's one of the big focuses in the strategy, right? So and he's kind of making those big investment areas, and because that's a big focus, he killed a few teams over here and repurposed those people to CI/CD teams. They're picking the big focus. Season is more about, okay, we know the focus areas. What are we actually going to do to deliver on those focus areas? Right, it's more focused on functionality. Is that accurate?
Yeah, I was wondering if it's like working at the smallest level, you're always working to that next biggest level, and it's always
There's no traceability between those two, if that's what you're thinking.
No, not like traceability is like a narrow down traceability, but it's more like a high level. We're doing the sprint goals to go against these planned goals, that go against these season goals, that go against these strategy goals.
Not as structured as you seem to be talking about it. And for example, even though the strategy may be these 3 or 4 focus areas, right? So for example, the manual test management, that's something that VSDS does, it's got a bunch of functions in it, that is nowhere to be found in the current year's vision. There's still a couple teams working on manual test management, and they present the storyboards of the season plan, right? So it's not necessarily strictly tied to the vision. But I think if people don't like what they see in the storyboards, the discussion may try to tie it back. If I don't like what you're showing me, I might, use the vision as a club and say, how does that help us get towards our goals in the vision? And then we do a three sprint plan. So every team, and this kind of goes against Scrum proper, every team is expected to have some idea of what's going to be in the next 3 sprints. Maybe not super detailed, but any time, the higher up management should be able to go and look in TFS or go and talk to the team lead and they should be able to bring something up that shows this is what we plan to do in the next 3 sprints. May change a couple weeks from now, but you gotta kind of have a plan, a rough plan for the next 3 sprints, which is two months or so of time, right? And you gotta continually update that. As the sprint finishes, your 3 sprint plan has to keep going out. And when we think about aligned autonomy, right, leadership is solely kind of responsible for strategy. The season is kind of a mix between the teams coming with storyboards and leadership telling them, thumbs up, thumbs down, or change this. The plan and the sprints, which user stories and tasks, if you're thinking BSDS terms, that's entirely the team's domain. Management leadership, if you use user stories and tasks, they never look at it. The season is features in TFS, and strategy is just a Word document. But that's what leadership looks at and cares about. All the stuff under that, you're expected to have some detail there, but it's kind of up to the team how you manage that detail level. Leadership cares more about the season and the strategy. And we use work items in BSDS to manage our work, obviously, except for strategy. We used to use epics for that. Now we just have a Word document. But typically we have features broken down into stories, broken down into tasks. Not every team, because stories and tasks is the team decision. But the leadership and the alignment is on the features. When we're doing those season meetings, we're looking at the features, or you might call them epics, in BSDS. And then teams will break those down further. But a lot of teams don't break it down into tasks at all. Some teams do estimating. Some teams do no estimating. Some teams use story points. Some teams use hours. I think very few teams use hours. Nobody likes estimating hours. But it's entirely up to the team kind of what to do with that lower level. Or even need to use stories and tasks if they don't want to. Right? They can have that 3 sprint plan just in features. So that's kind of where we break the barrier between aligning with strategy and autonomy for teams to do their own thing.
So there is no clear answer to the software estimation.
Every team does
issue.
it differently. We don't care. And I don't have the slide in here, but there's a slide I have somewhere which is what we measure and what we don't measure. And we measure work remaining. Well, that's not entirely true because we don't have estimates. But one of the things that we don't measure is original estimate and things like that, right? A lot of people like to measure original estimate and track our performance against it, because if we monitor our original estimates and the actual work, and then we can look at it and get better at estimating. Yeah, right, we do not care. That doesn't work. But some teams, some scrummish teams will do like remaining work in hours so they can have a burn down. Some teams don't do that, and they don't have a burn down, and that's okay. Management really doesn't look at burn downs. If teams want to use burn downs to manage their team, awesome, it's up to them.
The reason I'm asking is the agile purists, yeah, they bet on the poker game estimation and everything,
Story
but
points.
there are a lot of voices against this. So.
I tell you, when I lead teams, the teams I've led most recently, I do story point planning. Maybe not playing poker, but I still like to have story point estimates on my user stories. But within VSDS, those 40 teams, it's up to each team how to do it, and they all do it somewhat differently.
It's a tricky term though, agile purist. I don't know what that means. I don't know. But usually doesn't mean you have to do estimating and point. That's just people are being crazy and says you have to do this to be agile. You have to, there's not that many rules that you have to be that. The whole point is adapting.
Well, I'll tell you what, when leadership wants to know what's going on with the team, like what a team's most granular plan they're ever going to look at. They're looking at features in TFS, and they're going to look at the next 3 sprints, and they're going to look at what features are planned. They're not looking at estimates. They're looking at the next 2 months, what features are kind of on your plan, on your roadmap. They don't need any kind of estimates, work remaining, or nothing. There's a delivery plan view in TFS. They're going to look at that. Which features are in the next 3 sprints? All right, that looks good. Or hey, this feature is really important. Why isn't that in your plan? You got to yank something out and put that in. So they don't look at estimates, numbers, burn downs, nothing. Teams want to use that because they think it makes them more effective. Go for it.
We've been using story points to help us with what we call a burnout, and that's helping us track more at that level that you said, the feature level, which is, are you on track to meet the features that you need to deliver, basically.
Yeah.
And that kind of helps the executive team just sort of understand where we're at. And one of the downfalls too is that we've got multiple teams, and at that point, points don't mean anything because you can't use them to compare across multiple teams, right? So it's really a very narrow scope that we use it for, and we try not to focus on it just on estimation. It's more just like literally to help that burn up chart tool. We still do it because we see benefit from that burn up chart, but we try. I think you're right. It's tough. It's a little bit on that line. It's a balancing act on that
Yeah.
line. How much is
Well, and like I said, if our leadership, that they wanted to know what was done, they just look at the sprint mans.
right?
They want to know what's coming up, they look at the features on the 3 sprint plan, or the season, depending on what level they want to look at.
Right.
We have more pretty pictures of this, but we just talked through all this.
Dylan, how much of this applies only to the STS as opposed to, let's say, other teams such as Azure or Visual Studio or SQL Server?
So, interesting question. So, all of Microsoft is in the middle of a big DevOps transformation. They have made a decision from Satya down that our current engineering system or systems, mishmash of systems, are currently a competitive disadvantage. And Microsoft is making a big effort, they call it One ES, first party engineering system, to standardize on one engineering system, one build, one source control, kind of maybe one planning approach, not just systems, but process too, across all of Microsoft. And right now every team has like different tools and software. You want to standardize on one system. The system is going to be VSTS or be built by the VSTS team, maybe it doesn't exist yet, and with an eye to productizing whatever we build internally for customers. So there's a big transformation happening across all teams. VSTS and Bing are out far in front of the curve. Bing does some really, really cool stuff with how they do DevOps. So they're probably even ahead of VSTS.
More than even Azure? The
Huh?
Azure teams?
Definitely. I mean, Azure's better than Windows, let's say, but they're not as good as VSTS. So VSTS and Bing are out in front, and everybody's playing catch up, but there's a big push within Microsoft to get everybody caught up.
So there's a lot of attention to these two groups, the VSTS and Bing.
VSTS, this One ES initiative, the VSTS team owns it. So they're out there basically consulting with other teams to help them move forward. So for example, Windows and Office are somewhat recently all on Git inside of VSTS, which was there's a bunch of blog articles about it. It was a
Right.
very tough challenge. Windows is the biggest Git repo on the planet,
Yeah.
by far.
And they had to come up with their own file system for it.
They had to re-architect Git because it couldn't handle the size of the code base Windows had. So yeah, some interesting stuff there. I'm not touching that today. Talked about future team chats. One thing I'll talk about is kind of the journey to get from not Scrum to Scrum that worked well. So we started with one pilot team, and we tried Scrum, and we tried 3-week sprints and 4-week sprints and 2-week sprints, and kind of settled that 3 weeks worked good, and we wanted to standardize some length across the whole org. But another thing we tried, so we did one team, and then a few more teams, and eventually we said, all right, let's send everybody on Scrum training for a week, and kind of we're all going to do Scrum from now on. But we didn't do that from day one. We had some pilot teams. But one of the things we did at the start is, because our previous model was a big test and stabilize phase. It's longer than the coding phase. And people were worried, when are we going to test and stabilize if we do this 3-week sprints and deliver every 3 weeks? Well, they weren't delivering every 3 weeks to start. To start, they did potentially shippable at the end of every sprint. But they only shipped every few months. Now they truly ship every sprint. But anyways, stabilization. Some teams were really worried. If we do 3-week sprints, when's the stabilization period? So one thing they did at the start is they decided they're going to build in a stabilization period. After every 5 sprints, there's going to be, I think it's two sprint long stabilization period. Where it's not feature development, it's bug fixing and technical debt and refactoring and whatever you need to do to make your code better. And they did this. Most teams are already on the Scrum model. And they noticed that they had 2 types of teams. Team A, and that dotted line represents like tech debt. Either messy code that needs to be refactored or more commonly just bugs, lots of bug buildups that they didn't test fine and they didn't fix them. And Team A is good. It's kind of aggressively tackling it, never lets it get out of control. Always, paying down that debt as they go. And there's a bunch of Team Bs that just let it grow. And the reason a lot of these teams let it grow is they could have been like Team A, but they knew we got a stabilization, we got a month of stabilization coming up. Why fix those bugs now? Let's just leave them so we have some, we got a month, we need something to do in that month. Let's do more features, and we'll fix it all in that stabilization period. Right? Not very healthy behavior. And what's even funnier is when we get to that stabilization period, what do you think Team A did? They don't really have anything to stabilize.
It starts on 6.
You think they partied? No, they didn't start on 6. They didn't party. They got to help Team B fix bugs. Right? So this didn't work very well. A lot of teams just say, just get rid of the stabilization period. Just force us to keep our debt under control, and we'll do it. And so we got rid of it, and they did it. Right? And now You know, the old model, that's kind of how the tech debt curve went. It grew and went down in stabilization phases, and as that line went down, everybody's morale went down along with it. That's the death march. All right, now we're doing sprints. It's, you know, I think we've been quite successful at keeping it under control. We don't have stabilization sprints. One technique we use to do that is we have a bug cap. We have an engineering scorecard. I got a picture of it somewhere in here farther on. And this is on the scorecard. And every team takes the number of engineers on the team, multiplies it by 5, and that's the maximum number of bugs that team is allowed to have. 10 engineers, that's a bug cap of 50. If you ever have more than 50 bugs logged against your team at the end of a sprint, whatever your plan was for the next sprint, throw it out, you're fixing bugs for the next sprint. So every team, and when we first put this in place, lots of teams had to throw out their sprints and do bug sprints. Now it's quite rare. Nobody wants to do a bug sprint. And we look at the scorecard that has this metric for each team every day, all the time. So this is what we use to kind of monitor tech debt, bug debt, and keep it under control.
Who captures the bugs? How's that testing? Or when you're saying they're raising bugs, that it's the team within themselves are raising their own bugs?
Bugs come from lots of places. They come from failing tests in the build, they come from customers reporting bugs, they come from people dog fooding it and putting in their own bugs.
So it's whoever wrote that feature ends up.
When a bug gets put in there, at some point, I don't even know how the triage process works, but so at some point somebody triages it and figures out which team owns that bug.
So a question, you might be jumping ahead here, you might get to that. As part of this transformation, I see a cultural shift that has to happen there as well, right? When you implement that cap, how do you guys, essentially the commitment on a season and the plan could potentially be affected by that? So what happens in terms of that accountability on the teams to deliver those things?
There's the plans and the seasons aren't necessarily commitments. Nobody's going to come and yell at your team if we get to the end of the season and you didn't deliver everything you had in your mock-ups.
Right.
Right. It's to set expectations, to give us something meaningful, to have useful discussions around what should we be doing, what should we not be doing.
Sure.
If we got to push it out because we got bug sprints, it gets pushed out.
But the question I really have underlining that is that the culture that is there to begin with? There's a lot of organizations that don't have that culture to begin with, right? They set dates and then drive commitments from those, right? And it's like, well, the team ran into a whole bunch of issues, and now there's a commitment that's out there that could be effective.
There's no real hard commitments at least based around scope like that. All right, and we may be a little bit different as a product company versus if you're a consultant working for a customer and they're paying you for a certain set of features or something, right? It's more challenging. But there's really no firm deadlines for features per se.
But like he's saying, there's a lot of enterprise that hasn't made that shift yet.
Absolutely.
Microsoft's like far ahead of everyone else in that aspect.
Yeah.
You're right, like there is that in the top down, like you're delivering these and that's that and more. And there's no wiggle room. So it does require
For sure.
culture.
My counter argument to that when I'm in those organizations is you guys keep selling us as a product team and you're really not. Because that's a big difference
Yeah.
I generally see between like a product or a services oriented organization. But I'm just wondering about that.
Well, yeah,
aspect
so,
from
the
Microsoft.
cultural thing is the most important. Like I said, we do have an engineering scorecard that everybody looks at all the time with 10 or so metrics for every team, and they go red. Like bug cap's one of them. And if you get red on your engineering scorecard, it's very bad. People see
Right.
that all the time.
Right.
So it's more like
Because so really driven by the engineering culture who said, yeah, we don't want to do this again. We're using this as a continuous improvement item. We learned in the past that we had these spikes that just led us towards bug bashing, death marches. We don't want to do that anymore. So that internally, I guess they sort of adapted that in their
Yeah.
culture to say.
and if you ask the engineers who were there before these changes,
Right.
like, do they enjoy their job more now? Like
Totally.
no
Yeah.
question.
Okay.
Okay, so I'm going to talk about, next one is some engineering practices. Code, branching model, builds, PRs, and then I think I'll dive into testing. So when we realized we have to ship way more frequently than every 2 years, we had to do something about how we did branching. We always knew it was a mess. Don't pay too much attention to the details here. This is just a small snippet of the giant branch chart that we used to have. And the only point I wanted to make with putting this on is it was complex. It was Well, your laser pointers don't work very well. There's feature teams down here at the leaf nodes, but to get those feature teams codes integrated together, they talk about it, the multiple sub-branches, every once in a while, they would smash together and integrate into this branch. And then they come back down and stabilize, and once they get stabilized, this one and these other ones would smash together and everything would break, and then you stabilize it a bunch. And once they get smashed together far enough up and back down, then those feature teams codes gets integrated. It can take months before one feature team and another feature team code comes together. Not only that, but it was so freaking complex, the code flows in the old branching model. They had specific people, 3 or 4 of them, I think, whose entire job was to merge code flow between branches. Because it was so complex, your typical engineer, they might understand how to get from their feature branch to the one above it. But to get from here over to here, there's only 3 or 4 people in the organization who understood how that was supposed to work. And that sounds like the worst job in the world. I hope those people were paid a lot of money. They spent their whole day merging code that they didn't write. And lots of stuff went wrong. Stuff was integrated together. It could be months. If we wanted to deliver, every few weeks, there's just no way that this was going to work. There's so much integration debt that was built up, the tax on development and fixing those integration problems. There's just a huge drain on the whole team. So we basically threw everything out. What we do now, and it's pretty extreme, is conceptually, technically it's not entirely accurate, but conceptually, every developer, so there's 800 people, maybe 400 or 500 of those are developers who have new features. 500 of people work directly in master. They're committing, let's say, every day, hopefully, ideally, hopefully multiple times a day, and they're committing straight into master. Don't do feature branching, don't do release branches or anything like that. Everybody's working directly in master. There's a few things we need to do to make that happen, right? That sounds probably crazy, especially when you got 500 engineers working on the same code base. So we do a few things to make that happen. First of all, when I say we commit directly to master, that's technically not accurate, because everything that goes into master, we want to pull request it. So we use Git. And if you want to pull request into master, it needs to be in another branch first. But all we do there is, if I'm a developer, I write some code in the morning. When I'm done, or when I'm ready to check in, that feature may take me a week. When I'm ready to check in, all I do is I go and create a topic branch, /user, /Dylan Smith, whatever my feature is. I push it to that feature branch, I immediately pull request it into master. As soon as that pull request is done, that feature branch gets deleted. But it's only there for a short amount of time a day, just to allow me to pull request into master. So everything gets into master through pull request. Developers are checking in, ideally at least once a day. We have, I think there's a stat on there, 175 commits a day in master, kind of on average. But the other big challenge is, all right, well, if I'm working on a feature and that feature takes a week or a month, hopefully we don't have month-long features, but it takes a week to develop, so I can't check in for a week. No, we use feature toggles extensively. So every new feature that's more than a few hours of work, the first thing the developer writing it does is he figures out how to write his code and hide it behind a feature toggle. And he'll check that code in, and after a few hours of work with the feature toggle, it goes into master. If there's a deployment tomorrow for master, that half-finished feature goes out tomorrow. But the toggle's just turned off, so customers don't see it. We have a whole bunch of automated tests, we'll talk about that in a bit, that test that half-finished feature hidden behind a toggle isn't breaking the world. But every developer, every day is checking in code hidden behind toggles. When that feature is done, the toggle stays in there for a little while. It'll go out to production, it'll turn on for some accounts and off for others. Once it's on for everybody, somebody goes in there afterwards and deletes the toggle from the code. And when I say a toggle, I literally mean an if statement in the code, and a true-false value in a config file somewhere. Right? That basically says, hey, if the toggle is off, go and do the old behavior. If the toggle's on, go and do the new behavior. The easiest thing to hide behind toggles is if it's a UI feature. Okay, do I have a screenshot of that? No. But maybe we're adding a new button to the UI somewhere, and the toggle is, hey, just don't show that button if the toggle's off. But all the code behind it is still in there. So that's how we work out of master. Everything gets pull requested. Every developer checks directly into master. We hide stuff behind feature toggles if it's not ready to show to customers yet. Now that's not entirely true. There's a couple other branches you see in this picture, the yellow things. So we also, at the end of every sprint, when it's time to release, so at the end of every 3 weeks, we cut a new release branch that's named after that sprint. So the last one will be like S124. And technically that's where we deploy out. And our deployments, we'll talk about that in a bit, they take a week to hit all the users' accounts. We progressively deploy to more and more customers and more servers. So deployment takes a week, sometimes more. So at the end of every sprint, we cut a release branch when we release out of that branch. If we need to do a hotfix or a patch to production, we'll check it into that release branch, because that's the production version of the code. If we need to do a hotfix, we'll check it into the release branch, whatever the current active one is. At the end of 3 weeks, when we cut a new release branch, the old one basically becomes obsolete. I don't know if it actually gets deleted, but it's not needed anymore. If we want to do a hotfix, if we check something into master, it could be 3 weeks before it gets deployed. If we need it to be deployed faster, we'll check it into the active release branch. And the active release branch is actually deployed every single day. It's a scheduled daily deployment. And if we need it faster than that, we can manually trigger a deployment from the release branch. Right, so if I'm a developer working on code, I got to decide. Most code I'm working on, it can wait till the next sprint release. It goes to master. If it has to go out faster, I can check into the release branch. And what I actually have to do, I have to do a double commit. So we're not really doing a fancy merging strategy here. If I'm going to check something into release, I got to check into release and then cherry pick it into master at the same time. And that's it. That's the entire branching strategy. We got master. Every 3 weeks we cut a release branch, which we deploy from daily. I'm just going to pull this up in VSTS. I'm not going to show you screenshots.
One question.
Yep.
That master branch, is that development branch that you're talking about? Master branch?
Well, it's called master, and it's the only branch we have. Well, I don't know what you mean by development. It's the only branch we have, really, and we call it master.
Okay. But you do have release branches there?
Yeah, we create a release branch every 3 weeks.
Okay.
And after 3 weeks, they kind of expire and become unnecessary. We'll put a new one every 3
So
weeks.
it's kind of like the get flow minus the develop branch.
I would say it's nothing like GitFlow. I don't
No?
like GitFlow. GitFlow has like
No,
develop
more
and
like
integration
Gitflow.
branch and all this
Okay.
stuff going on and feature branches and dev branches. I mean, we have master and everybody works out of master. We have this release branch thing going over here that's minor, but we have one branch and everybody works out of it. It's conceptually how we think about it.
Do you have any mechanisms for your double commit?
We do a git cherry pick.
Yeah, but that's completely on the onus of the developer.
Yeah, well, when a developer checks into release, he'll get to check into release and master like at the same time.
Right,
Push to release, cherry pick the master immediately.
right.
Is master tested every day for every deployment and for every night?
We'll get to that. You know, in fact, I'm going to get to some of that right now. So this is the VSES code base. This is our Git repo. And here are the active pull requests. And if I look 3 minutes ago, 12 minutes ago, just to see how many they are. I think that was the time they were created. Well, everybody's taking pictures now. No? Oh, I thought I saw a camera. What's coming in VSTS, next release? Right, I'm scrolling down. I'm down to 22 hours ago, 23. So there's a lot of active pull requests, right? So this is very actively under development. And let me see if I can find a good one here. What do I want? I'm going to pick a completed one. I know, what I'm looking for here is I know if the date is old, that means that this pull request has bounced back and forth a few times. So there's probably going to be comments and stuff. It'll be a juicy one. All right, so we pull request everything. There's probably, and we do code reviews. Every pull request needs at least one other reviewer to approve it. You know, and it's just like GitHub or any other, most other Git toolings, we can have the discussions around the code changes here. One thing that we do, I'm gonna zoom in here. So VSTS, here's where I'm slyly pitching a VSTS feature that nobody else has. VSTS has these things called branch policies, and the team uses them a lot. So every pull request has a few things. When we submit a pull request to master, we have a build that kicks off. That build compiles all the code. It's gonna run 60,000 unit tests. We'll look at those in a minute. It's gonna do some other stuff. We run something called polycheck, which is an internal tool that checks for swear words in the code. It's not allowed. We have a couple other things. We have this cred scan, which is some internal tool we wrote. I think we're gonna release this as a product soon. It basically just scans code for things that look like secrets, things that look like passwords or certificates or keys or whatever. And if it finds them, it'll fail the build. We want people checking those in. One of the branch policies is a reviewer policy. So at a minimum, we need one reviewer. But we actually get a little bit more complex than that. If I go and look, I can remember where this is. Oh, I gotta.
So these are policies assigned to the branch so that no
Yeah.
code can be pushed to it
The way,
unless
the way,
it
it
needs
work,
that?
the way it works in BSDS is if you have any policies turned on, all changes have to go through a pull request.
Right,
And then the policies control what has to happen on that pull request before it can be accepted.
gotcha.
Quick question.
GitHub has the same.
I know right now you with a pull request you can automate it to do one build. Is there any idea in the future that you can maybe trigger multiple builds from a pull request?
We have, when I switch back to that last screen, there is multiple builds in there. Absolutely we do.
Okay. I know, yeah,
well,
the
here-
version I work with, it doesn't,
Alright.
it only allows for
Right here, build validation, pull request. You can't quite see everything. Where is it? Required and optional. We can mark them all as required.
Okay.
But these are our reviewer policies here. If I don't know, zoom in here. So teams, anybody can come in here and set up a policy that basically says, hey, if this pull request changes any code under here, you know, the security project or the security folder, somebody from the security team needs to review this code, or somebody from the Git team needs to review it if it's changed in the Git source report files.
Right.
If you look here, there's I don't know, 50 or so, maybe 100 of these reviewer policies set up to make sure that we get the right reviewers. And if people are really anal about reviewing everything that goes into the piece of code they care about, they can set themselves up in there. But yeah, so when I'm looking at
I
this,
like that, self-limiting. Well, because you're nominating yourself as the reviewer, right? So you've got to
yep,
balance it.
yeah. So sometimes you'll see multiple required reviewers depending on what files were changed. All comments resolved. So somebody leaves a comment, like a code review comment in there. It has to be like marked resolved until the PR can be accepted. We have some other stuff here. So these optional ones, and this must be a weird pull request because this is not the policies I'm used to seeing. Let me just pick whatever the most recent one is. Oh boy. Yeah, that's more what I'm used to seeing. These optional ones and these status ones, I'm not going to go too much into what all these things mean. But we have in the main build for the PR runs all unit tests, 60,000 of them. We'll put that in a second. We have another, 8,000 functional end-to-end tests. They're slower. They take a few hours. We're not going to run those in every pull request. We don't want to force developers to wait a few hours. But we have them set up as kind of optional builds, and we have them split up among like a bunch of different things. High priority ones, or Git functional tests, or work on functional tests in different areas in the code base. And all these various things in their status mean something around there. If I'm submitting a pull request, I have to run all the unit tests. I can click in here. Oh, not that one. Oh, it's because it's completed already. If this was still in progress pull request, I can click on this and I can say run that test suite. And it'll run it. You'll see it running here. You get a tick mark if it passed. Right, so if you're concerned or you want to build more confidence, you can optionally choose to run those functional tests or some of them. Or a code reviewer might come in here and think, yeah, you really should have run that test suite. You click the button and it runs on the pull request and life is good. If I go and look at, let's say, the build. You can see over here we got 61,000 unit tests. Took about 8 minutes to run them. They all passed. That's good. And then, there's a build that I'm not going to talk through the steps. But so when everybody submits a PR, all that stuff has to happen. It all gets passed, and all the code review comments are resolved. That gets merged into master. Once it gets merged into master, we have another build that runs called the CI build. Typically, it's not CI, but as soon as it gets into master, we run another build that runs all the functional tests. Right? It takes a few hours to run, runs all the functional end-to-end tests. We don't make the PR wait on that, but once it gets into master, we do run those tests. And not often, but about once a month, something makes it into master that fails the test. We didn't catch it in the PR, it makes it into master, fails the test. When that happens, somebody gets alerted, somebody jumps on it right away, even if it's 2 in the morning, and they either track down the developer that did it and get them to fix it, or they'll revert it right away. We don't let master stay broken, because 800 people are working out of it.
Is there's no feature that can actually lock down master in that event, is there?
I don't know how it works, but I know the team does have a way to do it.
Yeah. So I thought of that. It'd be nice No
Well, I mean,
one,
we-
you broke it, so no one else can basically integrate into master until it's fixed.
I mean, you can just remove permissions from pushing to master. Another thing we do, yeah.
I guess just one more question first.
Yep.
On your whole autonomy versus alignment thing,
Yep.
I assume standards of development standards of that is more on the alignment, the autonomy for teams, I would assume.
Like coding standards?
Yeah.
So surprisingly, we don't have much. And I was kind of surprised when I started digging into it. I'm asking people, show me all the static analysis you do. It's not competent, that's not rules.
Yeah.
I love static analysis, and I guess it's gonna be juicy. And like, we have nothing, Doug, nothing. We scan for swear words and passwords in the code. But it's not entirely true. So for the most part, I mean, teams are kind of free to use whatever style they want. But we do have some like architectural patterns you're expected to kind of stay within. For example, BSDS has a REST API, and they try really hard, too hard in my opinion, to stick to like the RESTful
Like hypermedia.
gospel, right?
Microsoft's published a whole guideline around REST.
Right, and they stick to it closer than I would ever stick to it, but anyways, they do, and there's many teams that publish REST APIs, and before they had REST APIs, they had like SOAP APIs, and they were a freaking disaster, and every team designed them differently, and they were just a total mess. So now they want to do it better, they have REST APIs, and they have kind of standards for what REST APIs to do, and all the teams have to follow it. Now, they don't really strongly enforce it. If you want to go and add a REST API in your team's code and not follow that standard, nobody's going to stop you. But, you know, when somebody notices it, what do you think you're going to be doing 2 sprints from now? You'd be going back and rewriting your API to match our standards.
Or they catch you in a code review.
Yeah, they'll probably get caught in code review. But if it doesn't, you know, eventually it's going to get caught, and you're just going to have to go back and rewrite it.
So you don't have the issue that people get in their subjective opinions of how code should look. And
I don't think that happens very much. I
because
mean,
a lot of times we just go with like MSDN guidance on how you should handle collections and stuff like that, right?
no, we do have, there's some document out there with like, it's not like, you know, put your curly brace on its own line or anything like that, but more higher level kind of architectural patterns. Like if we need to do locking, and we have what's called the Visual Studio Shared Services Framework. Anyways, we got like a library that we collect like common things, because we use microservices now. We might get time to talk about this, I'm not sure. So we split up into a bunch of microservices, but there's common stuff that every service needs to use. So we are constantly evolving. We're finding this common framework. You know, if you want to do locking, well, there's locking in the common framework. And if somebody goes and implements their own locking thing, hopefully somebody will catch it in code review and say, hey, you shouldn't reinvent this. Just use the stuff in the common framework.
Right.
Yeah, I think
Especially around security.
I think the most impressive thing is how you guys are able to actually pick up velocity in production as you go forward. You think the code base is getting bigger, it's getting more legacy, and usually that's when things slow down and you're just dealing with it. So that's, to me, I think that's the most interesting part of this. And usually it slows down, not speeds up, which is kind of, but that could be the way you guys architect things and make them small little areas, right?
Yeah, microservices is a big thing. We're still working on it. We used to have just one giant monolith.
Yeah.
Now we have 31 microservices and one giant monolith. We're slowly carving pieces off of it, but it'll be a while before we can call that thing a microservice. And new stuff we do, we don't put new stuff in that monolith. When we do new stuff, we're spinning up new microservices. We still got this big thing in the center of it all.
You do what most people do. Have one, instead of having one giant big piece of crappy code, they have 3,000 little pieces of crappy code. It's like,
Well, we have 31, so it's not 3,000. It's 31 microservices right now. I'm just gonna skip this. This is less interesting than the other stuff. Okay, let's talk about quality in BSDS and how we do testing. So I showed you 60,000 something unit tests, and I said we have a few thousand functional tests. How we do testing, not just like the technical details of how we write or automate. We do a lot of automate testing, obviously, but also how we structure our team. And you haven't heard me mention manual testers yet. So we've undergone in the team structure two shifts. In 1990, this is even before my team, we had, is it listed there? So we had a few roles. So first of all, people always think like this, the ratios. So we basically had developers, testers, and management people. And for every developer, we had, those numbers aren't right.
that seems like
Yeah,
really
1-to-1 developer tester
No.
and half.
And half
PM.
of PM.
Okay,
Like,
so
you
now-
guys have way too many PMs.
No, it's a lot worse than that. I don't know, my slide got screwed up. For every developer, we had 1.5 testers and half a PM. Those were the ratios, right? So on a team might have 2 PMs, 4 developers, and 6 testers. Those were the ratios. This is a couple decades ago. Testers are split into 2 roles: SDETs, software development engineers, and STEs. So all our testers are developers. They're writing code. So first thing is VSDS doesn't have any manual testers. Never have, still don't. And I'm not saying you shouldn't have manual testers. We can get away with it because we're special. We're building a product that's for developers, and we have 800 developers on our team, and they use our nightly builds of our product all day, every day. Right? We don't need manual testers because everybody on the team is a manual tester at all times. So we can get away with it. If we were building, an oil and gas software, we as developers wouldn't be able to dog food it and test it, and we'd need manual testers. But just through the scenario that we're in, we don't need manual testers. But we do have a bunch of testing people who spend their life writing automated tests. And the way that we used to have the 2 roles, SDETs and SDEs, is SDETs would write the testing frameworks and harnesses, and STEs would churn out the actual automated tests. And it sucked. Right, developers didn't have to write any tests. Developers didn't write unit tests, didn't write nothing. They threw it all over the wall of the testers. And do you think those testers wrote quick, small unit tests? No, because the code's not testable at all in any way. So every test they wrote was end-to-end functional tests. Not only that, but we didn't really have good APIs to set up test harnesses around to manipulate the state into the way the testers needed it to. So their test harnesses stuck their fingers into the internal state and using reflection to modify private variables to set up the state that they needed to run their tests. So now the developers are handcuffed because anytime they want to change or refactor anything, they're going to break a million tests, or they can't do it. They didn't care about can't doing it, so they just did it and broke all the tests. So we had, after many years of this setup, 30-something thousand end-to-end functional tests. They weren't UI layer tests. We've never really done UI tests. We experimented with it and realized it's just terrible. The tooling is atrocious. So we do API layer tests. And we had 30-something thousand end-to-end tests. They took about 18 hours to run. So because of that, we obviously can't run them on every check-in, so we ran them every night. And every day, we have 200 changes to the code base, and we run the test suite of 30,000 tests once a day, every night. And how often do you think that test run passed? Take it. We did it for 8 years. It never passed once. It came close one Christmas when people were on holiday and the code check-in slowed down. 8 years, never passed once. And every morning, the testers would come in. They wouldn't ignore it. Every morning, the test team would come in. They'd look at the failures from last night's run, and the whole team. If the answer was yes, we can release, they'd release. If any of them were no, we'd cut a new build and start that process over. It was hell. I don't know how they ever released anything back then. But we combined SDETs and STEs, but there was still kind of similar problems. We didn't really solve anything. Dev and test is still separate. So ultimately, what we did is we combined testers and developers into one role called engineering. Nobody's a developer, nobody's a tester. Every developer owns the quality of their code now. They write the tests for their code. And that was really challenging because, for one thing, when we were hiring back in the old world of SDEs and SDETs, SDETs were kind of a second-class citizen. We'd hire a developer, and we'd say, what, that guy's good, but he's not really good enough to be a developer. Let's make him an SDET instead. Let's hire him as an SDET. So you got these second-class citizens, and at some point, it was 4 years ago, where we collapsed it down, and we had to lay off a bunch of the SDETs. The reality was a lot of them just weren't good enough to meet our quality bar. It wasn't a huge number, but it wasn't a small number. Some of them made the transition to engineers, and a bunch of them didn't. And that was hard. I gotta slide somewhere on this. That was hard, but now we have one role, engineers. They write the code, they write the tests, they're expected to ship tests with the code. They're also expected to maintain the test harnesses. And this is kind of the culture thing. We're trying to restructure how we write our test cases and APIs, and that wasn't working. What really we had to do to make the change stick is we had to make engineers, developers care about quality and testing. And we did that by just making them responsible for it. You're responsible for quality of your code, you're responsible for writing the tests, for running the tests. In the old world of the 2 roles, the SDETs had all these fancy test harnesses. None of the developers knew how to run those test harnesses. So even if I'm a developer and I want to run their tests, I have no idea how to stand that up and run it on my machine. They know the voodoo to make that stuff work. But now we have one role. And just so you know, there are a couple other roles. It's not just program management and engineers. We have service delivery people. They're like the ops type guys. We'll talk about that if we have time. We got UX people. UE is user education, doc writers. So we got a few other roles. One interesting thing about our team structure is engineers report to engineers who report to engineers who report to engineers. You'll see that the engineers don't report to program managers. At the very top level, that top engineer, the top program manager, those guys come together, they report to Brian Harry, the corporate VP of the whole division. But under Brian Harry, engineers report to engineers, PMs report to other PMs. And then there's some, on the sides, you can see service delivery people really fall under engineering. But that's kind of how our team is structured. That's pretty much accounts for all 800 of the people within our team. Those are the roles. The individual feature teams, though, are obviously comprised of a handful of engineers and a handful of PMs. I don't know what the new ratios are, but it's quite a bit different than before. The PMs, we call them program managers, which is a really weird term. The more common term in the industry would be either product owner / business analyst. Right? Our PMs are responsible for deciding what we're going to build and why we're going to build it. Oh, Lori, did you do something with Slack?
I didn't do anything.
Lori, we're just telling the story of how I always leave my Slack on. And I could have swore I turned this off.
That wasn't me.
Where was it? Yeah, so our teams are still, feature teams with a mix of PMs and engineers. But the engineers on the team don't report to the PM on the team. They report to some engineering manager that they have. And the engineers are responsible for figuring how we're going to build it, and they're responsible to deliver it with quality, with tests. Nobody else is going to test it. There's no throw it over the wall. I kind of talked through a lot of these already. Oh, I will talk about this. So we combine the roles. Engineers are now responsible for test. We get all these test harnesses and 30,000 end-to-end tests, and they suck. They're terrible. And they go deep into the code and internal APIs in ways they should never do. They're slow as heck. They take 20 hours to run. So we knew we had a problem with all our test artifacts. And ultimately, we decided our 30,000 tests, we just want to press delete. We just want to throw them all out and start over. Now, obviously, we can't just throw them all out and start over. We got a product we got to ship every 3 weeks here. So this happens over time. But ultimately, over 2 or 3 years, we basically replaced, rewrote, or just deleted all the existing tests and went to a new test structure, test strategy. And I have some slides here about the strategy. I like the time here. Good. But on the left is kind of, so we call our tests L0, L1, L2, L3. Yeah? And these names, L0s and L1s, are basically unit tests as you know them. The app is not required to be deployed. The difference between L0 and L1 is L1 can do some database stuff, but just like to test store procs and crap. But L0s and L1s are unit tests proper. They run fast, very fast, fractions of a second, right? They run in the build. L2s and L3s are functional tests. The app needs to be deployed. They're going to come in at the API layer. They're going to hit the database. They're functional tests. The difference between L2s and L3s is L3s can actually be run against production. They're not destructive with data. So we run tests against production via SDS after deployments to validate it and constantly to monitor it. So L2s and L3s are functional tests. So our old test mix, basically everything's L3s. We didn't really run them against production, but everything is functional tests with a very small sprinkling of some unit tests in there. And that TRA thing at the bottom, that's like the test harnesses, the framework the guys have built to run. So we decided ultimately we want to throw that out. It's really very little salvageable. And we want to get to a world where, and there's some principles, I think I got them somewhere in these slides, but basically if you can test it with an L0, don't write an L2. Test it with, the farthest left you can. And most things can be tested with unit tests. And so we want to have a whole lot of unit tests that test everything, and then some smaller numbers of these other things to fill the gaps that unit tests can't really do. And I talked about the taxonomy already. And when we're looking at the pull requests and those optional test runs, those are the L2 and L3 tests, kind of broken out by different categories.
What about like load testing?
Or
is that not related?
So we do load testing. It's part of our release process. We release into, we call it pre-flight environment before we go to our real rings. And we do run some load tests on there. It's kind of separate from this process. And developers, there's special people who write and manage the load tests, are release engineer type people.
really more part of your CI process, whereas performance testing would be part of your delivery process?
Yeah, these are the developers, engineers are responsible for writing these along with every feature.
Are you using TDD?
It's up to the developer, not everybody, some people. So, like I said, developers get to choose how they work. If you're a developer, you want TDD, go for it, but we're not gonna force you to.
But you do have to write unit
You
tests.
do have to write unit tests.
Whether you write them first or last?
Yeah, we don't track code coverage, but you know, we do review it in the PR reviews, that there's a unit test for everything. There's a bunch of things people are looking for. Telemetry is huge, there's gotta be telemetry for everything. BSTS collects 8 terabytes a day of telemetry from production. 8 terabytes.
But developers, are they aware of testing philosophy? I mean, a tester knows more about how to test, and it has like third eye view, yeah?
That is an expectation of our developers. Every developer either has to know how to test well or has to learn it. Just like you gotta know how to write good code. We hire for it, we train for it. If you don't know how to write good tests, you're probably not gonna get on our team.
Can you elaborate a little more on how you train for
Well, I'd say we hire for it more than we train for it.
it?
But I mean, you know, we do mentoring with junior developers, just like we kind of train them on how to write good code. Part of that is writing good tests. You know, I don't think we have any formal training.
It's more
classes.
organic. It's organic.
It's more organic. We do have guidance like this, so I'm not going to go through all these, but we do have like principles and characteristics of what's allowed and disallowed for the L0 tests and the L1 tests, right? And someone here, I guess, this is our basically scorecarding that we use over the 2 to 3 year transition from the old test to the new test. So every kind of column here is a sprint. So this graph is real data. It represents about 2.5 years. On the very left, you see the orange is the old TRA test, the old crappy test. And on the right is we got 60,000 L0 tests and some small number of L1 and L2. And you know, we made slow but constant progress over 2 years. And people were looking at this every week to make sure we're making progress. There's more detailed breakdowns of this. Is these old crappy tests, what areas of the code base that live in, which teams own them. For some period of time, the engineering scorecard had a column in there for how many of the old crappy tests your team owns, and we expect you to make progress of getting those down over time and getting the new tests in there.
So these categorizations, are they simply just tags or labels on the tests themselves? Is that how you denote them?
I don't know. That's a good question.
It's probably something the rudder knows.
Yeah.
I think it might be naming convention, actually, to be honest.
Okay.
So you know that certain rudders only look for certain
Yeah.
things.
I think we actually do have the naming convention.
Right.
But yeah, generally the journey was, you know, we started with L0 and L1 tests. We had to figure out how to write them well because our organization never written good unit tests before. So there was a bunch of learning and back and forth, and people were looking at seeing some slide decks and documents about, hey, mocking strategy and, you know, classical versus mocking and interaction style of mocking, and what should we be doing here, and how prescriptive do we want to be in the guidance to our teams. They had a whole journey about figuring out what good tests meant. But basically, you know, start getting a bunch of L0 and L1 tests, figure out what they should look like, get a bunch of them in place, and then start really attacking your old legacy tests and either convert them or delete them or replace them. You know, or convert them to unit tests or delete them. Some of them will get converted to new L2 tests following our new conventions. And then L3 tests, which is basically functional tests we want to run against production, we're still on this journey. So we have only a couple experimental L3 tests. That's where we're investing right now. Right, and we track test time, right? Test time by test, by type, and by all the tests on a specific assembly. And we have certain budgets for those different tests that have to come in. Right, do I say here? Does it say the execution budget? No, but basically unit tests have to be, you know, hundreds per second. Oh, the other big thing, yeah, forgot about this one. So, especially in the old world with the end-to-end tests, we had a huge problem with test flakiness. Right? What I mean by this is you take a build, you run the test suite, something fails. You run it again on the same build and it passes. Right? And it was a huge problem because we couldn't test, or we couldn't trust our test results. We get a failed test, should we just run it again? Is it really a problem with code? We couldn't trust our test results. It was a massive problem. Going to unit tests instead of end-to-end tests just naturally made this a lot better. But it was still a problem, even in unit tests, but especially in our L2 tests, our functional tests. So we really made a big investment to do something about this problem. And our new policy is zero tolerance for flaky tests, zero tolerance. They just are a huge time sink, a huge drain on our productivity. And the way that we do that is we have some background process, a build server sitting somewhere, maybe a few of them. And every day or so, they're gonna grab a build, and they're gonna run the same test suites on it, all our test suites, 500 times over. And if something passes in one and fails in another, that's a flaky test. And we have an automated process that will go and take that test out of rotation on our real build. So it won't, well, it technically will be run, it just won't be included in the test results. Take it out of rotation, automatically create a bug that says somebody has to come and fix this flaky test. Figure out why it's flaky and fix it, or get rid of the test. We can't have it in there and be flaky. As soon as that bug is marked completed, some more automation runs, and that flaky test is put back in rotation. So we have this process running all the time, and we are, you know, from what I hear is we have almost no problem test flakiness anymore. This is just stressing this up. This is, oh, if I zoom in here, you can't see it. I'm gonna do this so I can zoom in. This is our engineering scorecard, and this has evolved over time. Try and zoom in here. So the rows are the team, and our teams are kind of grouped into different areas. The 40 or so teams. And every column is a metric, an engineering metric that we track. And on every basic presentation the team gives, our feature chats and season chats and their sprint emails at the end of every sprint, their row from this scorecard is on the top of every slide, and every email is very visible across everybody looking at anything. And this is where we put the metrics that we want our teams to care about. I'll tell you what all of these are. So for each team, and we have thresholds for each. The bug cap is one of these. And you see why it's green, red, or yellow based on whether they're meeting their goals. Your team doesn't want to be red. So we split this up into live site health and engineering debt. So live site health, this is, LSI is a live site incident. Production goes down as a problem in production. The team will attack it, mitigate it, fix it, do a root cause analysis. The result of that root cause analysis is usually, here's 5 things we got to do to stop this from happening in the future, to detect it earlier, to whatever. Those are work items tagged LSI. Teams have to jump on those LSI work items right away. So if it's more than two sprints old, shows up in here. You're supposed to have 0. % LSI completed in 2 sprints. God, what's DTSs? I can't remember what DTSs is. We're going to skip that one. Some perf scenarios, the engineering ones over here are the more interesting ones. So P0, P1 bugs, right, severe bugs. Number of severe bugs older than 21 days, you're supposed to have 0. Number of active bugs per engineer is supposed to be 5 or less. Right, if you're 4 or 5, I think it's red. If you're over 5, or it's yellow. If you're over 5, it's red. And these little spark lines, I think, is showing the last 3 sprints, the values from the last 3 sprints. We do something, I don't have time to really go in detail about it, but it's really cool, something called red team, blue team. You guys ever heard that? Yeah, some people
Only
nodding.
in a military context.
Okay, similar. So we have every quarter, we've been doing this for a few years now, we have a red team exercise. Lasts a couple weeks. And the red team is a team of paid hackers that attack VSTS production, try to compromise it. The blue team is a team of people who try to detect and defend. And we've been doing this every quarter for about 3 years now. We started by hiring outside consultants, like a penetration testing consultants, and paired them up with our developers to be the red team. Now we have full-time people on staff. VSTS does this every quarter. Azure has red team exercises going on at all times. They have a full-time red team. We do it every quarter, and they attack VSTS. There's very little rules of engagements. They can't take it down, but they can't target customer accounts. We have enough Microsoft accounts. They got to target Microsoft accounts, and they can't do things. It's funny. There's the rules. There's only like 4 or so rules written down. One of them is they can't physically intimidate people. They can't go and beat you up till you give them your password. But other than that, they can do almost anything. And they do phishing attacks and social engineering, calling up our help desk pretending to be somebody else. And so we've been doing this every quarter for about 3 years. Every single time the red team has run one, they have always completely compromised VSTS, got full administrative control, every single exercise, often in multiple different ways. The good news is it's getting harder for them. The first time they did it, they just scanned file shares for things that look like password and found a gajillion passwords that had been accessed. So it's getting harder. Now they have to string together several vulnerabilities to get in and escalate privileges and stuff. And the blue team's actually detecting them sometimes now. I've never stopped them. But for the first couple of years, the blue teams didn't even know what was going on. They just twiddling their thumbs, it's totally compromised, and they saw nothing. So they're detecting them sometimes now. So we're definitely making good progress. But another thing we learned is that phishing emails, targeted phishing emails, are incredibly successful.
Number one.
You will never. We've trained our employees a million times. I think we've learned that you will never stop phishing. Phishing is just incredibly successful, and you have to design your security in your application around the assumption that people will be phished out of their passwords, right? Two-factor auth and stuff like that. And I got some slides somewhere in another deck that shows one of the phishing attacks they did. And there's a few I've seen them do, like, hey, here's my site, I can't log in, help me out. But then one they sent out that was quite successful was, hey, Microsoft's doing a new pilot program with these new Samsung Galaxy phones. If you'd like to be involved, sign up here. This is a personal invite. Please don't forward this to anybody. Something like 60% of the people that got the email clicked on the link. Something like 10% of the email who got the email also forwarded on to all their friends. So we had people that were getting phished that weren't even on our distribution list.
Well, of course, if you want people to do something, tell them not to.
Yeah. Another thing that I thought was an interesting learning is your engineering systems are just as sensitive, more sensitive than your production systems. What I mean by that is one of the recent red team attacks is they compromised somebody's account that didn't have any access to Pro, no access to Pro, but they had access to edit the build definitions. So they went into the build definition, they added a step in there, and so a typical build def is get the source code, compile it, and put the artifacts somewhere, and maybe sign them, and they get deployed out some other automated processes. So just took a step in there, download the source code, and then download this patch file from my random Azure storage account and apply it to the source code. And that change is basically, here's a master password that gets me into anything. And the red team did that, added that step, let it be deployed out to production VSS. So they deployed out a vulnerability. They only they knew the master password, and they kept it very secure. But they let it be deployed out to production VSS, and now they had access to everything. So if somebody compromises your build server, you're owned. They own you. They can deploy anything they want to your production. And there's no audit trail because they didn't check in that code to TFS, right? They just applied it on the fly during the build process. And then it proceeded to get signed and deployed. Yeah, I didn't think security would be so interesting, but I think that red team stuff is just incredibly cool.
Do you have anything that's automated like that, like Netflix's use of Chaos Monkey?
Chaos Monkey, no,
Yeah.
it's actually it's one of the next steps on our journey, is like chaos engineering. We don't really do much with it yet. Okay, Lori told me to wrap up by 8:15. That's in 14 minutes. So I'm trying to think priorities. What do I got left here? I got architecture, and I got live site stuff. I think that's pretty much it. So I'm not gonna cut anything. I'm just gonna speed through it. So some interesting bits about architecture. I kind of mentioned that we went to microservices. In 2010, what we had is an on-premise product, and we wanted to move it to the cloud. And the way the on-premise product looked in 2010, we had just introduced some stuff that kind of allowed this to happen. TFS is basically made up of the database, an application tier, which is like a web service website, and some job agents. And in 2010, we had just introduced this concept of collections. If you don't use TFS, you create team projects, and team projects are grouped into team project collections, and each collection gets its own database in SQL Server. So in my on-premise TFS installation, I could have a few collections if I wanted to with a different database for each one. And we had the capability to load balance application tiers, to have multiple of them and load balance between them. So it was pretty critical to move in this to Azure. So that's where we're at, and our first attempt to move it to Azure is we basically just took what we had and we deployed it to VMs in Azure, in a SQL Azure database. And we really didn't change as little as possible. We had to change identities and stuff because there's no Active Directory. We just use Microsoft accounts. But we basically just took it all, stuffed it up there. Every customer, every VSES account was a collection and got its own database, right? So we weren't really multi-tenant. We had no automated deployments. I shouldn't automate these slides. We had no production telemetry, so when stuff went wrong, we remote desktop into the server and look at event logs like every one of our customers did on premise. Because it wasn't really multi-tenant, and we were just spinning up a new collection database for every customer, we very quickly got to the point where we had 11,000 databases in SQL Azure, one per customer, and TFS, the current architecture, it was set up to handle 3 or 4 or 5 collection databases, not 11,000. So at some point it just basically fell over and stopped working. So we had to do something to fix it. So that's kind of the architecture. We got some app tiers, and JAs, job agents, SQL Azure database, and that's basically what it looked like. They had to do some special stuff for identity. And every account got a new database. So the first thing we had to do is we had to make it multi-tenant, right? We had to have many accounts without many databases. Right, and I don't know if you guys, I work with a lot of customers that struggle with this. They know they should do that. But once you've developed it as single tenant, you know, and when you're starting your product, you're just going to install a new instance of your application for each customer, because we only have a few. So that starts to fall apart once you get to thousands of customers. And so, I mean, the better thing everybody kind of knows is, let's just put it all in one database, and let's add a column to every table that says this row belongs to this customer ID, right? And the fear there is now you have to update every query to filter by the customer ID. And if you miss a query, now you're going to leak customer data to another one. So everybody's always really afraid of this. You guys thought about this before?
Yes.
So they have a cool trick that they did. So they did that. We're going to add a column to every table. We call it partition ID, customer ID essentially. And we're going to update every single query to make sure that it filters on partition ID for the customer that we're looking at. We have a trick to make sure that we were very afraid that we were going to miss some queries, or somebody was going to write a new query and forget to filter and expose customer data. So in SQL Server, there's this thing called file groups, right? And basically says normally when you have by default in SQL Server, you have a database, you have an MDF file and an LDF file, which is your data on disk. You can choose to have multiple MDF files. And I'm not a DBA expert, but my understanding is there's some way to split up, even within a table. This part of the table goes in that file, and that part goes in this file. So they created two file groups, and by partition ID, and partition ID 0, which was a special one, that goes in this file group. Every other partition ID goes in this file group. Now, partition ID 0 was special. That was no real customer. There should be no data with partition ID 0. And then they intentionally took this file group offline and left it offline forever. So if you ever ran a query that didn't filter by partition ID, it would try to read from this file group and it would error. I think that's pretty cool. I'd never thought of that before. So one of the first things we had to do, I got deployment I got to look at too. Okay, we're going to skip live site and talk about deployment. This leads into it. So we're going to already have one database, but still, we kind of had one installation of TFS. So load balanced app tiers, sure. But once we get enough, it's not 11,000 customers anymore, but once we hit about 500,000, even that starts to fall over. The app tiers are caching stuff per account, and even if we have scaled out 7 app tiers load balanced, eventually once you get enough accounts in there, it just falls over. So now we had to introduce this concept of scale units, which is basically separate installations of TFS. And we had to kind of factor out some common stuff like billing and identity into our first microservice, shared platform services, which handles it centrally for like identity and billing. Something in a big break. Typically the blast radius of that break is going to be limited to that scale unit. And we'll stop the rollout and the other scale units will be okay and just that one's affected. So that's pretty valuable too when you're operating at scale. We have 31 microservices. That's some of them. TFS in the middle and kind of SPS a little bit too. TFS is the monolith. We got one big service that's all source control and work item tracking and test case management. And then we got like 30 other ones that sit around it, and we're slowly carving that up. I'm going to skip sizes. 31 services, 13 regions, 7,000 CPU cores. We're using web roles and worker roles in Azure. If you guys use Azure, you know those are ancient and long since obsolete. And everybody has a question, why aren't you using Azure websites or Azure functions or containers or something like that? And one of the short answers is that when we moved the TFS to Azure, none of those things existed. Back in 2010, it was just web roles and worker roles. So that's what we used, which are essentially VMs. And then we could have evolved to like Azure websites and the PaaS stuff. But our challenge is it's the same code base that we shipped to VSTS and to TFS on-prem. And 95% of that code is the same code. There's some small differences. If we start taking advantage of cloud stuff, like Azure websites and Azure functions, now that code diverges more and more. Now we got this code for Azure and this code for on-prem, and we really wanted to avoid that. Having said that, we are in the process of containerizing all of VSTS. And that will possibly result in an on-premise TFS that's shipped as containers in the future. Because now we can potentially use containers to keep it. Even if we don't ship it as containers, the code doesn't diverge very much. And another interesting story on why we're going to containers, another big reason is cost. A few reasons we're going to containers. Cost is one. It costs a lot to run VSTS. We're using basically VMs. We have 7,000 cores up there in Azure. The database is super expensive too. But when we stand up a new scale unit, and let's say it's a new region, right? When Canadian companies wanted us to stand up VSDS in Canada. Well, in order to do that, we got to create a scale unit in Canada. We have 31 microservices. We don't deploy any 2 microservices to the same VM, and everyone gets at least 2 for redundancy. Just to stand up a minimum size scale unit, minimum, it is 273 cores to hold one account. That's the minimum size. And some of them are bigger. When we get everything containerized, the predictions are that we will need 50 or fewer cores for the same minimum size, because we can pack more containers into one CPU core than you could VMs. So that's one of the big motivations for containers. And there we go, all the stuff I just said. Last thing I want to talk about before I run out of time is just very quickly how we do our deployment. I'm not going to talk about this stuff. Let me get to my pretty pictures somewhere. I have a lot of slides in here. Don't turn feature flags on the morning of a big keynote. Not good. So if you're ever at one of these, Microsoft Build or Ignite, and there's like VSTS in the keynote, or like Connect coming up next month, and you want to know about the new features before the keynote, just go log in like the night before, because they always turn them on the night before now. You don't want to turn them on the morning of, because they had a big problem at Build a few years ago. Right before Scott Goo or somebody got up on stage and turned on a flag, and down goes VSTS. Early deployments, we used to use MSIT, which is Microsoft Centralized Ops Group, and they managed the VSTS cloud infrastructure for us. And deployments were not automated. Deployments were one-note files that we gave to the ops team and says, here's all the steps you need to run. Here's some SQL statements you need to run, and look at the results, and based on if there's no issues in there, then go and deploy this package or whatever. We had manual deployment runbooks that we gave to MSIT. And when we first went to the cloud, we weren't shipping 3 weeks apart, we were shipping many months apart, and every deployment was just a hot mess. It was not fun. So now, everything's automated. There's a picture here somewhere. Nope, not that one. Everything's automated. Our builds, our CI builds, when the PR gets merged to master that runs for a few hours with all the functional tests, they spit out a build output that's about 10 gigs, and that's everything we need to deploy the service. Our deployments aren't actually full. We are not, technically speaking, continuous delivery. That deployment does not get kicked off automatically. Every deployment to VSDS, somebody's clicking a button to kick it off. But once they click the button, everything else is automated. And what we have, somewhere here, I talk about rings. Here it is. So we have the concept of deployment rings. So we have 40-something scale units. Every scale unit is kind of like a standalone installation of TFS. So we can deploy to a scale unit separately. But we have 40 plus, and we don't deploy 40. We don't manage 40 things. So we group them into 5 rings, and we deploy to ring 0, and then ring 1, and then ring 2. And we design the rings. Ring 0 is one scale unit, and it's a scale unit that the VSDS team uses themselves. So that always gets deployed to first. If we break something with a new deployment, we find it first in ours. Scale unit, there's some stuff that we don't use though. We don't use manual test management in VSDS. So if there's problems in that, we're probably not going to detect it. So after scale unit 0, it's going to go to scale unit 1, ring 1, which is another scale unit with early adopters and actual customers, MVPs, and people who've chosen to be early adopters, and hopefully they test out the features that we don't use. Ring 2, and I don't remember, but basically ring 2 is maybe somewhere in a non-US data center. Ring 3 might be 2 scale units instead of 1, so we test parallel deployments. And then ring 4 is everybody else. And when we do these automated deployments, every 3 weeks, here I got on the next slide, I think. Every 3 weeks, we deploy from master, the sprint release, and we do progressive exposure. So we will deploy to ring 0, and then we will wait a day, 24 hours. We call it bake time. We let it bake. And we're not doing anything special. We're just waiting for 24 hours to see if anybody freaks out and alarm bells start going off. And after 24 hours, if no alarm bells go off, it automatically goes to ring 1. You have to explicitly stop it. We have a wait thing built into our release pipeline. Nobody stops it. After 24 hours, it goes to ring 1. Waits another 24 hours, ring 2, and so on and so forth. We have daily deployments scheduled for more important fixes, and they have 1 hour bake time between rings. But everything goes through the rings. And if it's, production is down, we need to get that fixed out, we can override those bake times, hopefully responsibly. We're doing, some of the things we're doing is instead of just waiting 24 hours and hoping no alarms go off, some of the next steps on our journey is putting more kind of proactive monitoring in place, actually running some tests against it and looking at specific metrics. Right now, some people do that sometimes, but it's more just so, did fire bells go off? If not, all right, we're good. We use VSTS release management. That is our actual release pipeline. I could bring it up in MS Engine if I had more time in my web browser. But it's, we have this visualization stuff in VSTS, and we can see the rings, and it progresses through them. We use our own tools to deploy it. One thing that we do that's interesting is we do no downtime deployments. I could talk for a whole hour on how we do that. If you've ever tried to do that, it's very tricky if you have code changes and database changes that go together, right? Because you got to deploy them at the same time, but they both take time. Which one do I deploy first? So we have a whole complicated thing that we use to do database deployments without actually taking the app down. But one thing that we do is we split up our binary deployments, and so our binaries go first, and then the database after. What that means is that every code change we make has to work with the old database version and the new database version, and the developers have to consider that when they're writing their code. It's painful. It's a little bit painful for them having to do that, but that's the price that we have to pay until we find a better way. So we can safely, in theory, deploy our code changes and then database changes after. We actually deploy the code changes and then wait an hour, and then deploy the database changes, and then 24 hours bake time. And we do that because if we deploy the code first and something really breaks, we can roll back those binaries easily to the last one. Once we deploy the database schema changes, there's no going back. There's no rolling back database changes, and then restoring a backup if we really screwed it up bad. But once, we don't have any downgrade the database scripts. So that's why we do code first, because we still have a small window to roll back that code change. Okay, I'm going to skip this section. I'm going to wrap up. So let me get a couple slides at the end. Lori, why are you laughing?
I get that.
Fast. All right. All right, here we go. Here's my email. You said I had to leave 15. 1 minute. So to wrap up, a ton of things changed, right? And I haven't even talked about live site, or we do a bunch of other stuff for security. It's a huge, long journey we've gone on. Almost everything about how we work has changed. The big learning that we had is you got to focus on culture first, and practices will follow. Try to figure out how to instill a culture where people want to do the practices so you're to be successful, not just tell them to do the practices. The other thing that we learned is, it's not just simple to go from where we were to where we are with unicorns and rainbows. But it's also not chaos. We're not just randomly wandering around trying to get to our destination, right? It's a very deliberate process of trying things and seeing what worked and didn't work, and then trying something new and seeing if that worked and didn't work. So it's not chaos. It is a deliberate, conscious, explicit choice to go on this journey of continuous improvement, and it's a journey that's never done. Right? We're not done with our DevOps transformation now. We're containerizing the service. We're building L3 tests into our pipeline. We're going to do chaos engineering. We got to break up that monolith. Right? The DevOps transformation journey is never done. So that's it. Thank you very much.